Hello everybody, welcome to another exciting episode, and this is Dunia's Chronicles. I'm your host Simon, and as always my co-host is here with me, so as I believe you can have enough time with both of us today. And today we have an amazing topic to discuss. I'm pretty sure this is one of the most fascinating things that has been going on the internet and the medias and everything, and we've just thought it last time that it will be more important if we bring someone who knows much about what we want to talk today. And as you know, there are so many informations available online concerning our changing climate. We get last comment for the past two videos that we posted last time, and the guy says this was one of the most funny thing he said. He just said the climate is changing, and it has been changing way before you've been here, and it will continue changing over and over. So I think after deep discussion last time, we finally decided that it is better for us to start things afresh. It is more important if we can have a trip. And the trip that we decided to go actually is to go back ancient times, back in the days. And one thing that we want to discuss today, it is about the past climate. I think it will set up a very good base for whatever lies ahead for us to talk and discuss more. And as usual, there is somebody stopped by for a conversation today. And as you know, we always invite people who knows what they are doing and what they've been doing. They've devoted their life and work, and they've done a pretty good job to do so. And today I'm not going to be the main host. My friend will take over from here, and we'll be having more discussion with our guest plus introducing who this person is and what they've been doing, and so and so. So without further ado, ladies and gentlemen, please relax by it, take a cup of coffee. If you haven't, invite a friend or anybody else, and let us take this trip back together. Let us go back in time so as we can figure out what happened back in the days. This is Dunia's Chronicles. I'm your host Simon, and here is my partner Aditya. How are you?
I'm good, Simon. Thanks for having me. It's a pleasure to be back on the episode. And today we are joined by a special guest, very special to me. She's one of my co-supervisors for my PhD, and it's my pleasure to welcome Dr. Josephine Brown, Jo Brown, as we like to call her. Welcome to Dunia's Chronicles.
Thank you. Nice to be here.
Yeah. So for our listeners, Dr. Jo Brown is now an associate professor of paleoclimate modeling at the University of Melbourne, and she works on a bunch of things, on the Australian monsoon, on variability and changing climates, and she also works on past climates, which we are going to be talking about today. So Jo, first of all, congratulations on becoming associate professor quite recently. How are you feeling?
Thank you. It's actually not official till the 1st of January, so I'm just a senior lecturer today.
Yeah, well, we'll be soon an associate professor. But yeah, would you like to talk to us a little bit about what you do in your day-to-day work life, as particularly in your research about past climates?
Yeah, sure. So I use climate models, the computer models that we run to look at the future, but I use them to go back in time. And so we run the computer models for a range of different past climates that can be interesting or relevant for understanding the climate system. And we can talk about some examples later, but some of my favorites are the last glacial maximum, the last ice age, and also going back a bit further, the Pliocene, when the climate was warmer than today.
Right. So you look at past cold climates, but you also look at past warm climates. And this just goes off the question or the comment which Simon was talking about earlier. You know, a lot of people who watch these videos are not necessarily familiar with the science of climate change. people often think, our climate has been changing forever. Like, why is it so surprising that our Earth is warming when it has warmed before and it's been cold before? But given your expertise, would you like to add something? What makes the current climate change so different from the changes in the past?
Well, it's a few points. I mean, one point is the rate of change. So how fast our climate is changing is actually really unusual. When we talk about climate has changed in the past, we're usually talking about changes on timescales of, say, hundreds of thousands of years or millions of years, whereas the change that's happening now is actually happening over less than a century. So it's much faster. In terms of how large that change is, it depends on how much greenhouse gases we end up putting in the atmosphere, how much we see warming in the future, but it may take us back to climates that were similar to what we saw many million years ago. So probably the 3 million to 5 million would be the most recent example. And of course, humans were not walking around then, so we're not adapted to living in a climate like that, and it will be a very, very big change that we will need to adapt to really quickly.
Right. Yeah, so this is fascinating. So one of the things which I picked up on was, millions of years ago. That's such a long time ago. And when we talk about past climates, one of the questions that is quite common, and also something I have wanted to know as well, is how do we trace things back to that far back in time, 3 to 5 million years? Like, what type of information do scientists use to go back to that time period and understand, I don't know, what weather was like back then, or what the climate was like back then?
Yeah, that's a really fascinating question. So we climate modelers definitely can't do it by ourselves. We have to work with a whole range of people who collect different kinds of, we call them proxy records, because of course there were no weather stations to directly measure things like temperature or rainfall back that long ago. But we can get an indirect record from these proxy records. And so examples would be ice cores, ocean sediments have information in them. We can drill down into lakes and look at the pollen in a lake, which tells us about the plants that were growing in the past. What we call speleothems, so cave records like stalagmites and stalactites. There's lots of different archives in the natural world that tell us about either past temperature or past rainfall. Okay. So that's what we typically use to reconstruct the climate. It's like 3 million or 5 million years ago. And obviously, the more records that you can bring together, the more confidence you have in that past reconstruct.
Right. So it's a collective effort across lots of disciplines.
Exactly. Yeah.
So how do they give us an indication? Like, for instance, if we were to say ice cores, what is it about ice cores that tell us what happened and when it happened? Like, how do we know?
Ice cores are a really valuable record because they have a couple of pieces of evidence in them. So if you imagine drilling down a kilometre into the Antarctic ice sheet, you're basically going back in time, and there's layers of ice that were the snow that fell thousands and hundreds of thousands and millions of years ago in that ice sheet. And so the information that we get firstly is the water itself, which is H2O, our favourite molecule, and that has oxygen in it. Mostly it's the ordinary type of oxygen, but there are a few slightly heavier, we call them oxygen 18 isotopes of oxygen in that water. And it turns out that the ratio, how much of that heavy water, the O18, compared to the normal O16, is actually a record of temperature. And so scientists can basically plot how that's varied through time, and it matches up with what we think happened to temperature going in and out of ice ages and then into the warmer periods and then back into the ice ages again.
Right.
So that's the most common sort of information that we get out of them. But the other cool thing about ice cores is they have little bubbles of air trapped in the ice. And those bubbles are actually just samples of the atmosphere when that ice sheet or when that bit of snow first became very sort of compressed and sealed off the bubbles. And so, for example, you could go back 800,000 years and look at how much carbon dioxide or methane there was in the atmosphere at that time using those little bubbles. And so if you look at how the CO2, the carbon dioxide varies through time and temperature, you see a really fascinating variability that goes up and down together through the ice age cycles.
Right. Okay. That's very interesting. So basically, the ice has, it's like a time machine. You can tell from the components in it what was going on back then.
Yeah.
Sort of like a indirect indication of what temperatures and our planet was like back then.
Yeah, exactly. And we have a really long record from Antarctica. It can take us back almost 1 million years. They've got a 800,000 year long record. And then Greenland is only about 100,000 years because the ice sheet's not as big.
Right. Also, as a follow-on from that, but how do we know, is it 800,000 years or is it, I don't know, a million years? How do we distinguish?
So each archive has different ways of dating. For ice cores, they can actually directly count the individual layers, the annual layers that are in there, and they can also use sort of the chemistry of the ice to date back in time. So it's pretty confidently dated. Ice cores are one of the easier records to date. Some of the others are a bit trickier. You have to use carbon dating and things like that.
Right. So that's about, I guess, talks to us about some of the ways in which you can find out about past climate change. But how can that teach us about the current climate change? How do we use that information or how does it help us in understanding current climate change and, I don't know, understanding future climate change?
There's a few different ways, I guess. One way is to tell us what the range of things that the climate system can do. So, for example, we've only got direct measurements with temperature thermometers and so on for about 150 years. But if we go back further, we can find out, actually, it was hotter or colder or warmer or drier in the past. So that's a kind of a baseline for seeing how the climate's changing now. And then if we go back to climates like the Ice Age or the past warm climates like the Pliocene, we're going kind of outside of that recent historical period to see, actually, what happens to the climate when there's no Greenland ice sheet?
Right.
What happens to the climate when, the sea level changes and there's a land bridge from Northern Australia, for example? So
right.
There are lots of things in the past that can teach us about how the climate varies. And also it's a good test for our models, because when we run our climate models for the future, we want to have confidence that they're doing a good job. And so one of the tests we can do is to go back to the past and see whether they're actually able to reproduce what we think happened during these different past climates.
Right. So you have these big computers which run the climate of the past, and then you have these information to compare it with. And that can tell us if these big computers are good. Is that so?
Yeah, exactly. Because if we're not able to get a good simulation of the last ice age, for example, then there must be something wrong with our models. Maybe they're not sensitive enough to some kind of information that we're putting in. So we use that as a pretty hard test for a climate model, because they're designed to do a good job for the present day. They're not designed to do a good job for 21,000 years ago, but actually they do. And so that's encouraging.
Right.
Yeah.
So that's interesting. So based on that, and you talked about there are warm periods in the past. So based on all of this information, from different types of data records, from our computers and models, how do those warm periods compare to the current warm period? And what happened back then that caused that warming versus now? You used an example earlier. Would you? What happened?
There's a few different examples that the paleoclimate scientists like to focus on. Mm-hmm. One of the big ones is the Pliocene, which was, I say, about 3 to 5 million years ago, where we think that temperatures were about 2 or 3 degrees warmer than today. And so that's kind of in the ballpark of where we might end up this century if we don't act to stop emitting. And also the CO2 levels were higher during that Pliocene time as well. So the CO2 levels may have been about 400 or maybe 450 parts per million, which is kind of in the range that we're expecting to get to this century,
Right.
if we don't stop emitting. So I think that's seen as a pretty relevant, we call it an analog, basically a comparison. However, obviously it wasn't humans burning coal and oil that caused that.
Yeah.
So there are some differences in what caused it, but I think some of the patterns of change can be relevant. Yeah.
Right. So is it mostly due to natural factors, like maybe, I don't know, maybe the Earth was closer to the sun or other things?
Yeah, not so much on that time scale. Those kind of like orbital changes are more relevant for the Ice Age cycles. But for the Pliocene, it was just a part of a longer-term trend that we've seen actually over the last 65 million years. We've seen a gradual trend from the very warm climates that actually sort of more of the dinosaurs, back in the Cretaceous and so on. We've seen a gradual cooling trend over the last 65 million years.
Right.
If we go backwards to the Pliocene, it was a little bit warmer than today and CO2 was a little bit higher.
Right. And since then, we have seen a cooling trend.
Yeah, it's funny to think that our climate today is actually part of the cooler part of that last 65 million years.
Yeah.
Or relative.
But most recently, something happened which...
Until humans started to meddle with the system, that's right.
Right. That's interesting, yeah. And do the models which we work with and the past climates, do they also guide us in ways in which we can mitigate? Like, for instance, I often think humans were not back then, but there were other species, and lots of species, I don't know, many species may have gone extinct, but many species even survived warmer, colder climates. But can we use that information in ways to help us in the future?
I mean, I guess we know that when the climate changes, species usually migrate, if they can, to more suitable, like cooler or warmer or wetter or drier regions. And, even only 100,000 years ago, the last time the Earth was a little warmer, we know that species were migrating to cope with that. But of course, today, humans have taken up most of the available space. And so it's harder for a natural environment to adjust and for species to migrate around. As for us, I guess we're probably outside of the natural processes in that way. We're probably more likely to adjust, I'd say, using technology rather than, migrating to cooler climates or whatever, although people will do that as well. But in terms of mitigating, I guess we know that there are lots of parts of the climate or the Earth system that can soak up carbon. The ocean does a great job on longer time scales. It does get drawn down into the deeper ocean, and eventually, if you wait long enough, millions of years, it gets deposited into sediments and stored in the rocks and the geological reservoir. But we probably don't really want to wait that long. There are some suggestions of geoengineering approaches that could increase that rate of CO2 being drawn down into the deep ocean. I'm definitely not going to comment on that. It's way outside my expertise, but people are looking to, use some of those examples from past or geological climates to perhaps think about where carbon can be stored and increase that.
Yeah. I mean, I think in present day there's a over reliance on using technology, I guess, and maybe that's well found in some way or the other, but it's I consider it to be an over reliance, in my personal opinion, on using technology and just technology and focus on that to draw down carbon rather than actually focusing on mitigation and the natural cycles. But as you said, maybe we are already out of that sort of natural ability in present day warming outside the natural cycle of variability of the climate. But would you consider that the current warming is not just part of the natural cycle? I mean, we know that it's greenhouse gases, but if we were to suddenly stop warming, could we reach those earlier levels that we used to experience, the natural cooling trend that was going on in the Earth system before humans messed up?
Well, if we say we're able to reach net zero and stop adding more carbon into the atmosphere, so next year, then most of that carbon would still stay there that we've put in for a pretty long time, actually. There's been research and it's shown that some of it could still be there for tens of thousands of years. So we'll still see some effect in terms of an overall warming. And the slower parts of the climate or the Earth system, like the ice sheets, will probably still keep melting in response to that for thousands of years. And sea level may also continue to rise just because there's kind of a time lag in the response of sea level rise. So I guess we can't turn back the clock in terms of our human impact on climate very easily, but we can certainly reduce that impact and make it more easier for us to adapt to, I guess.
That's really interesting. The reason why I asked you this is because, and we have had this conversation before on the podcast about long-term changes as a result of human-caused warming. But I guess I wanted also your perspective of past climates, in the sense that maybe the changes that we are making are sort of like a permanent sort of regime shift in the climate system, and so beyond what was happening naturally before the Industrial Revolution.
Yeah, I mean, we've sort of had this idea or this understanding that our climate in the last around 2.5 million years varies between ice ages, which last for quite a long time, like 90,000 years, and shorter warm interglacial periods. And there's been this natural cycle of the last couple of million years. And many researchers think that we're actually pushing the Earth system outside of that sort of natural cycle and into a whole new regime, like you say, a regime shift, which could be, they call it a kind of a hothouse Earth, where it's the CO2, the greenhouse gas, is just too high for us to actually go back into our natural ice age cycles. And so I guess we'll stay potentially in that warmer regime for long enough for the millions of years for the carbon to be drawn down. But it depends a lot on how warm we get. We may not actually have reached that regime shift point yet. There's still a lot of discussion about that.
Right. Okay. That's very interesting. A lot of people often, and even in some of the comments, say that climate change predictions are often exaggerated. That climate models are overestimating, or maybe some say they're underestimating the changes that are going to take place. But what's in your opinion about the history of climate changes, and about the risks of rapid or slow changing climates in the past, from your perspective?
Well, one of the things that past climate research teaches us is that there's actually quite a lot of surprises in the climate system. And there are these kinds of changes that we sometimes call tipping points, where a kind of a gradual change can cross over some threshold or tipping point and become quite rapid. And so at the moment, a lot of our future planning sort of assumes that things are just going to continue on in a fairly steady way with gradual warming. But in the past, we've seen that sometimes a particular part of the system, like the ocean circulation in the North Atlantic, or the monsoons or something like that, can actually...
Or the glaciers.
Exactly. The glaciers can actually start to change pretty rapidly. And so I think that is kind of one of the key lessons, really, from looking to the past, in terms of knowing that these unexpected changes may happen, and also trying to work out a bit more confidently when they're likely to happen. Like, what's the warming threshold where we need to start worrying about the Greenland ice sheet, for example, collapsing, or the West Antarctic ice sheet, or the ocean circulation in the Atlantic, slowing down or stopping.
Right.
We can look at the past and try and work out where those thresholds are.
Right. So would you say that the key message is that it's not that these things haven't happened, like these types of tipping have happened before, but the human influence sort of pushes the whatever naturally happens to go even further, or maybe tips it from what was happening before to a different, a different regime.
Yeah.
Would you say that the human influence just exaggerates what was
Exactly.
Yeah?
So, I mean, definitely the climate has varied in the past, in both gradually and in these more rapid ways at different times without human involvement. But human activity now is just kind of pushing, as you say, pushing that system potentially closer to some of those tipping points, and also kind of outside of the range of what we're used to and what we've adapted our cities and our food systems and everything else to cope with a certain range, and potentially pushing outside of that range, which is problematic.
Right. So would you say that we should be, as listeners of the podcast, and from my own perspective, would you say we should be concerned at the moment on what's to come based on your experience of current levels of warming or what could happen in the future?
Yeah, I mean, I think it's a little bit alarming when we look at the past times where climate was only 1 or 2 degrees warmer, only CO2, carbon dioxide only a little higher, and how different things were. You see whole regions becoming much wetter or drier. We saw massive increase or rise in sea levels at that time because of the melting of the ice sheet, the Greenland ice sheet in particular. So relatively small changes. It doesn't sound very much, does it? 1 degree or 1.5 degrees, 2 degrees doesn't sound like much, but when that's the average change over the whole globe, can actually lead to some really big impacts. So I would say yes, we should definitely be concerned, and we should definitely take action to avoid those higher levels of warming.
Right. Also, one of the things which I personally find interesting is a lot of changes in the past also happened because of major volcanic eruptions or major asteroid impacts or large meteorites falling, causing lots of dust and debris and things like that, which we love to see in our books and movies. And could that, volcanic eruptions or potential impacts in the future, they could maybe, mitigate climate change in a way in the future, or make it even worse? Or is it what is your experience from the past studies or past climate studies that have happened before regarding this stuff?
Yeah, there's a lot of research in the impact of volcanoes on the climate. I guess we know from the last 100 years that there's been a few big eruptions, like Pinatubo in the Philippines in the 1990s. And that typically causes cooling because of the aerosols that block out the sun's radiation and make it, for about a couple of years, usually 1 to 2 years, it's a bit cooler. And so I guess if we had a series of large eruptions, that could cause short-term cooling, but it doesn't last very long because those aerosols just kind of get washed out of the atmosphere, and that effect doesn't stay. There are a couple of examples in the past 1,000 years where there were 50-year periods with quite a lot of volcanoes erupting, and they were a little bit cooler on average, so you can have a kind of a longer-term effect as well. But there's not much evidence that we would expect that to happen in the near future. We might get lucky. If a volcano erupts underwater, though, like we saw in Tonga recently, that can actually put lots of water vapor into the atmosphere rather than the aerosols, and that actually has a warming effect.
Interesting. Which
is a little bit different. So, as I understand, there has been a slight warming over the last few years as a result of that eruption in Tonga.
Wow. So it's not necessarily just cooling. It could be an opposite effect as well of warming.
Yeah, and on the very long time scales, of course, volcanoes also release carbon dioxide. So if you have enough eruptions over a longer period, that can be the driver for overall warmer climate as well.
Okay.
Yeah.
So the cooling effect is more or less temporary and on shorter time scales.
Yeah.
Which is that's very interesting. That's a useful insight we can gain, I think. I think on a lighter note, if someone wants to explore past climates or studying past climates, would you have any recommendations, books or things to read? How can people start learning about all of this? Because it's such a fascinating subject, not just, science, but it also affects, human evolution and other aspects.
I mean, actually, there's some really, really nice popular science books that have come out in the last few years, introducing different aspects of past climates. There's a nice one by Michael Mann. Unfortunately, I can't remember the title off the top of my head, but it came out about a year or two ago, and he basically goes through all of the examples that I work on as well, these past climates, and talks about what we can learn from each one. So that's a good place to start.
Okay. Yeah. That's amazing. And would you have any final thoughts on, what has your whole experience been in terms of past climates and future climate studies? And, why did you start studying past climates? What was your motivation to do something like this?
I guess I've always been fascinated with the past. As a kid, I think I wanted to be a paleontologist at one point. And then sort of coming into climate science at the time when lots of people were mostly working on the future, I thought it would be pretty interesting to kind of go back in time and look at what we could learn from the past. And these days, there's actually a lot of work together. Like, we tend to work on both past and future together, which I think is great because it means we can learn from, past examples for the future, and also we can make use of all the amazing climate models that are being developed for future climate research and run them for the past as well. So I think it's actually a really interesting time to be involved in this kind of research. But also, it's obviously a time where there's a lot of things that we need to be aware of and communicate to people who make decisions, I guess, the governments and so forth, that on the long-term baseline of past climates, we're actually starting to really move outside of what we've seen for a long time. It was in the last IPCC report, actually. They said, this recent change is unprecedented relative to these longer-term the last 800,000 years for greenhouse gases and things like that. So it's starting to be brought into discussion about the future, and using the past to kind of give that reference point, if you like.
So it is slowly starting to become a part of the mainstream policy making, trying to understand what's the long term, what are the changes we are making in the context of the long term climate of our planet. Yeah, that's good. And I think it should become a big part in the future as well. Simon, would you like to join in on the conversation?
Oh, yeah, it's a lot of things that to unpack from the conversation today. There's a lot of things that we can learn from the past. And I always say that I think you remember our best phrase that we always like to use it in here. Those who controls the printed pages controls the thinking of ages, and it is more important to make sure that you equip yourself with enough education and valid information. And right now, social media is there are some valid information in there, but it's way too polluted. You'll be confused, and I think to have valid information, it is better to listen, read, and understand, and get yourself some understanding. Do your own research concerning these matters about climate change, about everything, so as we can reduce the panic we have right now. If you want to be in trouble, we'll learn that in a hard way, that start talking about climate change or anything about net zero emissions or anything about it, because it has been involved with the politics and a lot of things. So it's a little bit complicated. I just have a question, though. The question is, what actually is the impact of a politics mixed with a climate knowledge, climate information? And we've started to understand now, politics start talking a lot about these things, and the public, since they have a huge influence on the public usually listen a lot to politicians, and they pay little attention to people who actually knows these things. What is your thought on this?
Yeah, I think as scientists, we can get a bit frustrated, actually, because we've been saying this stuff for a long time now, right? We've been talking about this I did my PhD 20 years ago. We've been talking about it for more than that, maybe 30, 40 years. Climate change is real. We need to do something about it. And it's not really getting through. So I think it's great to use all the different avenues like podcasts and things like that to get out to wider audiences. Because at the moment, if you pick up the newspaper, for example, or turn on the TV news, you don't really see much about climate change. It's like, it's not, sometimes there's a natural disaster, but otherwise it's not really a top story anymore. But it is actually so important. It really touches everything from health to, money and the economy to what's going to happen for, future generations, how their lives are going to be. And so I think somehow we got to find a way to keep it on the front page or keep it on the top of the agenda. Not that there are not other issues. Of course, other issues are really important, but we need to address climate change so that we have the ability to deal with all the other challenges that we need to face as well.
And I think one thing, actually, the public they are confused, actually, or they have been brainwashed to understand the role of a scientist on these things. We actually understand, we know that, science is not religion. It's not like a Bible, Quran, or any kind of religion or text that it doesn't change. It can be updated. It has been flexible for ages for that way. And that's why people keep on exploring as the new technologies surface, that the new information coming along the way. We keep on learning as more as we do research and understanding. And these pollution mixing politics as well as the climate information, as well as scientific information, public got confused. And right now, if you go to the TikTok, Instagram, Facebook Reels, or anywhere around the world, when you just start listening, politicians, people with influence, and others, when you can feel like you can get, okay, people don't like to watch this kind of videos. And when they start listening about what scientists start talking, they always, start attacking, abusing, all those kind of using different phrases and all that. Because you remember last time we had an issue with one of our listeners who started using abusive language, and we had to remove most of the comments in there. And we've explained that there is an important way to do this thing is to understand where we came from, so as we know where we are and where we're going. And as we always say, this is when people, if you mess up with informations, and people have a difficult to understand what is the reality. Well, we see the climate extremes, the increasing of extreme events all over the world, and people complaining, but they don't listen to those who actually knows about these things. If you do a research right now, the first concept about climate change, about the increase of CO2 and its impact on global warming, surfaced since 1930s. If you can see that timeline, they've started to pay attention in late 40s and 50s. And until today, we haven't even come to a conclusion like this is what we want to do. There is always adjustment. Right now, there is the fight between those who have been developed and those who are developing. Those who are developing feels like, okay, you guys have developed over the years. You got all the benefits, the infrastructures, the improvement in industries and everything. Now you talk to us whom we've just started to improve the living situation within our borders. You come to us and tell us to reduce the emissions, and you pose all these policies about taxes, carbon taxes, and all those kinds of policies to us. And then you tell us, okay, you don't have to do much of it. Let us just pay you certain kind of money, and then you can stop doing certain kind of things. And then once you join to the global market, your industry can do A, B, and C's. For example, paying about how much you emit is obviously people thinking like, okay, see, this is not fair. Okay, I'm not so sure about the finalization from the economy issue they wanted to put on the, especially during COP. Not sure how much they have agreed so far, but we've seen that there is a disagreement in it, and people say that it's a kind of scientific information are used actually on the negative side to impose negative political domination all around the world. What do you think we can do further to make sure, as a scientist, as a researcher, we separate ourselves from it, because we produce the information and are publicly available for everybody? But there are some policies in other countries actually. Before any information goes public, the government have to review it. If they disagreed with your point of view, because science, you need to have a freedom of your mind, a freedom to express based on what the data says, right? So when it gets polluted, it's a little bit difficult to know what we can do when it comes to these kind of things. What do you think?
I mean, yeah, I think the scientist's first job is definitely to provide the information, and ideally it should be freely available to everyone.
Yeah.
But then I guess sometimes we also try to get involved in a little bit in politics by, talking about what are some pathways that we could take, to have a future where we don't emit greenhouse gases, but people still have a decent standard of living, and that's the challenge. And of course, there's a whole injustice or inequality in the global economic system. And I mean, there's ways of tackling climate change which will make that worse, and there's ways of tackling climate change which will make that better. And I really hope that we can follow a pathway that's more focused around climate justice, and that, of course, the onus should be on the rich countries, the developed countries, to cut their emissions first and fastest, and then we can provide support to other countries to take a non-fossil fuel development pathway. And there are a lot of technologies now that should allow people and countries to, improve their standards of living without relying on coal and oil, and in fact probably end up with a more resilient, economy and so on if you actually take that renewable pathway. But, there definitely should be I'm not an economist, but I think there should be a lot of aid and support to enable that. I think there's a massive historical debt, if you like, from the developed world, from the global north, and that needs to be paid to make sure that whatever happens as we tackle climate change is done in an equitable way.
We definitely apologize if you have a difficulty listening to us based on the background noises, but we'll do our best to filter the background noise. I'm pretty sure it won't be much of a trouble, and since we are right now summarizing all today's episode, here's one thing. I think it's more important as scientists started filtering informations and providing more information. If we can see in the media right now, when someone all of us just sudden start producing misconceptions about maybe religion, maybe about culture, anything, those who knows much about the culture or religion always make sure that they debunk the concepts. They make sure that for providing valid information, so they listen and then they make clarifications based on a reality. And I think it is more important once in a while and most of the time that we have to start doing that, so as we can clarify information and make sure that public receive more and valid information. And as you've said, nowadays even scientists have tried their best actually to make sure that the information goes on public are digestible. They're easy to understand. Anybody can read and understand, which is a good thing. Make sure the podcasts are available now, books and everything. But guys, as I say, there's a lot of things that you have to understand. Social medias and all over the internet, there are real concepts and there are misconcepts. There are informations, and you might find yourself enter an area that is heavily polluted, and you might not get the real information concerning what you really want to do. Here is an advice. Read the books as you have been advised today. There are easy to understand books concerning difficult scientific informations. Nowadays there are some easy to understand publication. As different journals nowadays, they highly encourage scientists and researchers to provide easy to read manuscript. So there are valid information, there are valid places that you can get information. Make sure you got yourself a valid information. And on top of that, make sure you do enough research before start talking. Because whatever it is that you are saying or you are going to say, it will end up impact someone whom you have an influence on. That's a very important thing to consider. And whatever that might be on somebody's mind, it might impact the next generation. And we always understand that. Those who control the printed pages controls the thinking of ages. Thank you so much for today's episode. I'm your host, Simon. I was with my co-host, Aditya, and our guest. Do you have anything to say?
Thanks very much. It was a very interesting conversation. And if you want to know a little bit more about the climate science, there's also a couple of good websites, Real Climate and Skeptical Science. Both really good websites to get some fact checking.
There you got it. There are some information, and we will make sure we put the link in the description box for you to go there and get those informations and research for yourself. Until next time, enjoy the warmer weather for upcoming week here in Melbourne, and all in all, have fun. Enjoy. The climate is beautiful. Until next time, Simon Williams signing out. Bye-bye, and this is Dunia's Chronicles.